I think that's good. Yeah, okay. Bismillah. So I'm just making this to explain to myself, right? So I'm thinking of just recording a video and just explain to myself what's gonna happen. So let's just do this. I'm gonna read this. Start again. So there's a greedy algorithm. Greedy algorithm is basically it goes step by step and it finds the most optimal solution at each step, right? So at each step it finds the most optimal solution. So and then it never makes a decision, blah blah blah. It isn't important. And interval scheduling. So basically we have in interval scheduling, so there is one problem. The first problem that we are going to discuss in greedy algorithm is interval scheduling. In interval scheduling we have so we are given two lists. So there is an S list, right? There is an S list and there is an F list. So S is the starting time list and F is the finish time list, right? So there is, for example, we have like a list of problems. So there is R given, right? So R has list of n activities, right? So there are n activities, and in the S list, start list, right? There will be for each activity there will be the start time will be given, and for the F list, for each activity the finish time is given. So it's indexed based on the activity number. So R1 will have, so activity 1, so S1 will give you the starting time of activity 1, and F1 will give you this finishing time of activity 1. So here, for example, if you look at an example, right, there are different approaches to do this. Like to do the greedy algorithm, there are different approaches, right? So the first approach is earliest activity first, right? So when you go to earliest activity, for example, we have three activities here. There is the activity 1 given here, so there is activity 1 here, there is activity 2 and activity 3. So when you do earliest, so what we're trying to find here, okay, optimization, select a maximum size set of mutually non-interfering activities. So we need to find a maximum size, the most number of activities we can do, right, without any interfering, without any overlapping. This is what we're trying to find. So if we have these three activities, okay, and we try to find the earliest, so you can see this is like this arrow here, this the direction here is time. So time starts here 0, so this is 0 hour, this is 1 hour, this is 2 hour, this is 3 hour, blah blah blah. And in this example, this activity 1 starts at hour 1, right, and it ends at hour 10, right? And activity 2 let's say starts at hour 2 and ends at hour 5. This one starts at 7, ends at 8 or whatnot, right? Just give an example, right? So now, as you can see, activity 1 is the earliest one to start, right? And it is also, unfortunately, the last one, the most latest one to finish. And when you use the approach of earliest activity first, what happens is as in, what does it mean by earliest activity first? When it says earliest activity first, this is the approach we're taking. That means we schedule the activities which start the earliest, right? So we schedule them first, then we schedule the rest of them, right? So imagine we have this like a list of items, right? We have like a list of, I mean, it looks like a stack, but no, it's not a stack. I'm just saying a list. So this is the first activity, second activity, third activity. I have sorted them like in this order, okay, by the earliest to latest, right? So 1 starts the earliest, as you can see, it starts at hour 1. This starts at hour, let's say 3. This starts at, let's say, hour 8, right? So we have this starts at hour 1, this starts at hour 2, this starts at hour 3. So if we started this one, we say, okay, 1 is the earliest one, so we schedule 1. So we schedule 1, we put it here, we have fixed it, right? We fixed it. Then we come to 2, we say, oh, is it possible to schedule it, or does it overlap? If it overlaps, we don't schedule it, right? Then we go to 3 and we see, does it overlap? Can we schedule this? No, it does overlap with 1, so we cannot schedule this. And the final result is our selected list, like our selected set, right? Saying set. So selected set is basically just one activity, and that is the activity number 1, okay? And this is not the most optimal one. The most optimal one in this scenario is 2, right? The most optimal one is 2 set. Like in the set there will be 2 items, there will be 2 and 3 is the most optimal. We have the maximum size, right? We're looking for the maximum size, and the most optimal one will be, if you look at this, I remove this, the most optimal solution will be 2 and 3. So in our set we'll have 2 and 3. This will be the most optimal solution. But the solution we got when using the earliest activity first approach is we got the solution with just 1 in the list, and this is not the most optimal. This is the most optimal, and this is what we want. So now we're going to try another activity, another example, right? Okay, here another counter example is given. A single very long activity with an earliest item. So there is one really long, this is another example for the same earliest activity which doesn't exactly work, right? So here we have like this really long activity here, and this one is the earliest one to start, and this is the last one to end. And so the optimal one will be these 3, right? 3 will be the most optimal, what we get as 1 when you use this approach of earliest activity first. And another counterexample as well. Here we have 1 and 2. Okay, no, this is another approach, right? Now we have another approach. This approach is basically shortest activity first. Now if you look at this, this is saying this takes 1 hour, this takes 5 to 8, isn't it? Starts at 5, ends at 8. That is basically 2, right? 2 minus 1 is 1. 8 minus 5 is 3. It's supposed to be 3. No, it's 2 written here. Is it 3 or 2? Anyways, this takes, let's say, 2 hours. This takes 4 hours. This takes 3 hours. This takes 5 hours, right? And so we schedule it, right? We schedule it based on the shortest one. So as you can see, 1 is the shortest one, so we schedule that, right? Then we find this one is the second shortest, so we schedule that. Then we come to here, this 3, and we see that it overlaps with this one, so we cannot schedule this. When we come to 4, we see it overlaps with this one, we don't schedule this. We come to this and we see that it overlaps with the number 2, so we don't schedule this. And the result we get is 1 and 2. And this is not the most optimal. The most optimal one will be 3 things. Here we have 2 things. The solution we got is 2, but the most optimal one will be with 3, right? So this approach is also not a very good approach. All right, so there is another counterexample with the similar idea. So this is the shortest one. 1 and 2 are the shortest ones. 3, 4, 5 are longer ones. And you can see we first schedule these 2, and then we try to schedule this, but we cannot schedule this because overlapping. We cannot schedule this and overlapping. We cannot schedule this because overlapping. Okay, now we come to the next approach, lowest conflicting activity first. At first when I saw this, I was very confused. This thing, well, it looks very confusing, but then after trying to understand it for a while, now I believe I understand it. So lowest conflicting activity first. So what we're trying to find here is, for each activity we find the number of activities that it conflicts with, right? So the number of activities it conflicts with. So here you can see this one, this activity, right? This activity, this activity, it conflicts with how many activities? So as you can see, this one has a overlapping, it overlaps with this and this. So there is 2 activities, 1 and 2 activities that it overlaps with, and therefore, and that is the reason why it is written 2 over here, right? It's 2 here written because it is overlapping with 1 and 2. Now if you look at this one, it is overlapping with 1, 2 and 3. So it is overlapping with 3 activities, that's why there is 3 written here. This activity is written 4 because it is overlapping with 1, 2, 3 and 4. So there are 4 things. This is 1, this is 2, this is 3, and this is the 4th one. So there are 4 activities that it is overlapping with, and that's why there is 4 written here. Similar case with this, similar case with this, similar everything, similar case. So you can, so it's basically writing the count of overlapping activities for each of them, right? And then we schedule based on first schedule the activity that overlaps the smallest number of other activities. So as you can see, this is the one with the least number of activities. Okay, so we schedule this, then we look at the next one which is shorter, then we see this is 3, so we schedule this, then we schedule this. Okay, then we come to this and we see that we've scheduled 2 and it overlaps. Then we come to this, we see we schedule 3, it is overlapping. We should come to this, it's overlapping. So we cannot schedule any of these because we schedule based on the lowest conflicting overlap activity first, and we schedule this one, we schedule this one, we schedule this one, and the answer we got is 3. In our set we have 3. So what are we aiming for? We are aiming for maximum size set of mutually non-interfering activities, and the set size we got is 3, and this is not the most optimal one. The most optimal one is 4, as you can see clearly, very clearly here. This will be the most optimal one, right? This one right here, this 4 of them will be the most optimal solution, but we don't get that one when using the lowest conflicting activity first. So this is also not the best approach for us to do. So now we are saying, okay, none of the previous blah 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 blah, and now we come to the last I believe the last one, right? The last approach, which is earliest finish time first, right? So what do we do? As you can see here, we have these activities to do. So we schedule based on the earliest finish time. So we schedule this one because this is the earliest one to finish. As you can see, there's 1, 2, 3, blah 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 blah. This is the one to finish early, right? There's nothing that finishes before this. Okay, and we schedule this. Then we come to 2 and we see, okay, this is the second one to finish, but it overlaps, so we cannot schedule this. Then we come to 3 and this is the third one to finish, right? Then this also we cannot because it overlaps with 1, right? It overlaps with 1. Now we come to 4, right? We come to 4, this is the fourth one to finish, right? And therefore we see that it does not overlap with anything that we've scheduled already. So only one we've scheduled so far is 1, and 4 doesn't overlap with 1, so we can schedule it, right? Got it? And and then we come to number 5, which is the next one to finish, right? We come here and we see that it overlaps with 4 and 1, so we cannot schedule this. We come to 6, we see that it overlaps with 4, we cannot schedule. We come to 7 and we see that it doesn't overlap with anything that we've scheduled before, right? Doesn't overlap with anything we scheduled before, so it doesn't overlap with 4 or it doesn't overlap with 1, so we can schedule 7, so we schedule it. We come to 8, same thing, it overlaps with 7, it overlaps with 4, and also it overlaps with 1, so we cannot schedule this. So that is that idea. Now yeah, basically it's just showing you the step-by-step approach. Proof of correctness, I think that's another topic.